Good morning, students. I welcome you all to the chemistry online class. Student, I hope that you have studied the extraction of aluminum and its physical properties, chemical properties, and uses. Today, we are going to discuss about the next extraction process, that is the extraction of iron from hematite ore. First, we can see the ores of iron. See, iron is the second most abundant metal that found under the earth crust. Okay, so most available metal is aluminium. Next to the aluminium is iron. Okay, wow. Aluminium is also highly reactive metal, like that iron also highly reactive metal, and it occurs in the nature in the combined state. Okay, since it's more reactive, it can easily combines with other metals, and it is exist in the form of oxides. It can be an oxide ore, a sulfide ores, and carbonate ores. Okay. Now we can see what are the ores of iron. There are three major ores. One is hematite, next one is magnetite, the next one is iron pyrite. What are the three ores of iron? Hematite, magnetite, and iron pyrite. Among these three, the iron is extracted more from the ore hematite, hence it is called as the chief ore of iron. Already we studied the chief ore of aluminum as what? Bauxite. Here it is hematite. Okay. Now we can enter into the steps. The extraction of metal from ore mainly involves three steps. Do you remember what are the three steps? The first one is the concentration of ore. Second one, the extraction of metal from the concentrated ore. Third one, the purification or refining of the metal. These are the three major steps that involved in the extraction of metals from ore. Likewise, here also these three steps are there. First one, the concentration of ore. Here we are using the method gravity separation. What is the other name for gravity separation? It's a hydraulic washing. We know that already you studied this. The powdered ore is fed on the corrugulated table. The table contains grooves, and the water is sent at a high speed. The stream of water is passed into the crushed ore. So as a result, what happened? The lighter sand particles and the impurities are washed away by the water, whereas the heavier particles will be settled down on the grooves of the table. Okay, so this is the technique used for concentrating the ore, that is by gravity separation or hydraulic washing. The next step is roasting and calcination. Okay, after concentrating the ore, again we are going to do a new steps. We are going to do a step called as roasting and calcination. Do you know what is roasting and calcination? See, roasting means the ore is heated in the excess air. Okay, ore is heated in the excess air, whereas calcination means ore is heated in the absence of air, or we have to give limited supply of air. So that is the difference between roasting and calcination. See, after concentrating the ore, after cleaning the ore by hydraulic washing, the next step is roasting and calcination. In roasting, if you are following roasting means, what they will do in roasting, they will heat the ore by supplying excess air. If you are choosing calcination, the ore is heated either in the absence of air, or they will give only limited supply of air. Or else we can say it's a total absence of air. Okay, that's the difference between roasting and calcination. Depending upon the ore that we are choosing for the extraction, we will go for roasting and calcination, isn't it? See, if it is a sulfide ore means we will go for roasting. If it is a carbonate ore means we will go for calcination. First itself I said it's a highly reactive metal, hence it will be in the form of what are the types of ores. Oxide ores are available, sulfide ores are available, and carbonate ores are available. Iron is found attached in the form of oxide, sulfide, and carbonates. So oxide means we will go for gravity separation, sulfide means we will go for roasting technique, and if it is in the form of carbonate means we will go for calcination. Clear? So based on the ore that we are using for the extraction process, we will choose. So roasting means ore is heated in the excess amount of air, and this is used only for sulfide ores, and sulfide gas is produced along with metal oxide. Okay. Calcination, this is for carbonate ores and carbon dioxide. Sulfur will be removed in the form of sulfur dioxide gas. Here carbonate that is used to removed in the carbon dioxide along with metal oxide, Are you clear? So here we are using hematite, that's why we are using gravity separation oxide ores. If it is in the form of sulfide and carbonates, we have to do this step also. What step we have to do? Roasting and calcination. Roasting means heating the ore strongly with a limited supply of air, means it is what? A calcination. So what happened while doing this roasting and calcination means, as a result, the moisture that's present, isn't it? We are concentrating the ore. By gravity separation, we are sending lot of water. So that water will be get evaporated. Along with that, if our iron ores contain sulfide and carbonates or arsenic, phosphorus, other metals that we will consider as impurities, isn't it? That all are will be oxidized and it is removed off as like sulfur dioxide gas and carbon dioxide gas. Have you clear, students? So first step is concentration of the ore by gravity separation. If it contains sulfide and carbonates, we will go for roasting and calcination. While doing this process, the impurities such as sulfur, arsenic, phosphorus which is attached to our hematite ore will be removed in the form of sulfur dioxide gas and carbon dioxide gas. And also the moisture content that are attached to our ore also removed. Clear? The next step is smelting. What is smelting? The introduction part we studied, isn't it? Smelting is a process of reducing the roasted metallic oxide from the metal in its molten condition. So now the ore is what? We have did roasting. So the roasted, in roasting we get metallic oxide, remaining all are removed in the form of gases. So the roasted metallic oxide we get it from roasting and calcination. From this we have to separate the metal in its molten conditions. So this process is called as what? Smelting. So we are going to separate metallic oxide, that is we are going to separate iron from the its oxide form. Clear? So next we are going into smelting process, the last process, reduction process. Here the smelting takes place in a specially arranged apparatus called as blast furnace. Okay, smelting process takes place in the apparatus named a blast furnace. This blast furnace, what we have to add means, see, we have to prepare the charge. For electrolysis we prepared electrolyte, isn't it? What are the things we have done? The molten alumina, then cryolite, we added fluorspar, isn't it? So we prepared electrolyte. That like this, here in the blast furnace for smelting process we have to prepare charge. Charge means nothing, it contains the roasted ore plus coke and limestone. The mixture of roasted ore, coke and limestone. Here roasted ore means it's a metallic oxide, iron oxide, isn't it? Hematite ore, Fe2O3 plus coke, it acts as a fuel for burning. And limestone, it acts as fluorspar. What is fluorspar? Acts as a reducing agent. Clear, students? So we have to prepare the charge. Charge consists of mixture of our roasted ore, that is hematite, then coke act as fuel, and limestone which act as fluorspar. And it is taken in the ratio of 8:4:1. The 8% roasted ore means off of that we have to take coke and 1% limestone for reducing the fusion temperature. And this is added in the blast furnace. You can see at the top of the blast furnace there is a cup and cone arrangement at the top. The opening at the top. Through that opening we have to send the iron ore, coke and limestone. Okay. And inside the blast furnace the reaction takes place in 3 steps. The reaction takes place as 3-step process. Okay, that is combustion zone, fusion zone and reduction zone. See in the picture it is given. This is the structure of blast furnace. At the top we can see the cup and cone arrangement. Through this arrangement we are adding charge inside the blast furnace. Inside this blast furnace we can separate it to 3 regions. Lower region, middle region and the upper region. Okay. Or we can convert into 3 zones. One is combustion zone, lower region is called as combustion zone, middle region is called as fusion zone and the upper region is called as what? Reduction zone. Now we can see what will happen at the lower region. So we added the charge inside the blast furnace. Then we will send a hot air from the bottom of the blast furnace. Through the pipe we will send the hot air. Okay, what happens? The temperature, while sending the hot air, the temperature is nearly 1500 degrees Celsius. What's the temperature prevails inside the lower region of the blast furnace is about 1500 degrees Celsius, nearly 1500 degrees Celsius. Here I said the coke acts as a fuel. So when we are sending the hot air, the coke burns with the oxygen that is present in our hot air. Okay. So what happened? I already in the electrolysis we studied graphite contains what? Carbon. Like that coke contains what? Carbon. Okay. Coke also contains what? Carbon. Carbon burns with the oxygen that present in the hot air and they produce carbon dioxide gas plus heat is evolved. It is an example for exothermic. Liberation of heat energy takes place. So it is called as exothermic reaction. So carbon that present in the coke reacts with the hot air containing oxygen and they produce carbon dioxide gas plus they are evolving heat outside. So they are liberating heat. It is called as exothermic reaction. At that time the lower region, that is called a combustion, burning process, nearly 1500 degrees Celsius. Okay, wow. Next, what will happen? The middle region, that is called as fusion zone. Middle region is called as fusion zone. Here the temperature nearly comes down from 1005 degree, it lowers to 1000 degrees Celsius. Okay, from 1500 degrees Celsius, the temperature little drops to 1000 degrees Celsius. And what happened in this region? So already in the lower region, carbon dioxide gas is produced. Again, it reacts with the carbon that found unburned, that present in coke. Isn't it? We are adding nearly 8%. Our ore means 4% we are adding coke. In lower region itself, all the cokes are not completely burnt. Something remains left. So with that carbon, the carbon dioxide thus formed again intact reacts with the coke that found unburned inside the blast furnace and they produce carbon monoxide. Can you able to follow this, students? A few, for example, 4% means 2% of coke burnt. At that time itself we get carbon dioxide. In that the formed carbon dioxide finally fastly reacts with the unburned coke carbon. That is, coke contains what? Carbon, and they produce carbon monoxide. And this reaction is endothermic. That is, for this reaction it absorbs the heat energy. So it is endothermic reaction. So it can be called as what? Endothermic reactions. Hence heat is absorbed for this reaction. It is called endothermic reaction. At the same time we have added limestone also. This limestone acts as a fluorspore, isn't it? So it reduces the temperature. So what they happen? Limestones, what is the formula for limestone is CaCO3, calcium carbonate. Okay, calcium carbonate undergo decomposition reactions. Here the two steps reaction taking place. One is the formed carbon dioxide intact react with the carbon and producing carbon monoxide. At the same time our limestone is break down into carbon, that is carbon dioxide gas plus calcium oxide is formed. Okay, limestone decomposes into calcium oxide, CaO, and carbon dioxide is formed. It also absorbs the heat energy. It is also, for this reaction it absorbs the energy. So it is both are endothermic reaction. The first one and second one is endothermic reaction. Hence the temperature from 1500 degrees Celsius falls 1000. Again it undergoes it comes nearly 400 degrees Celsius. So now we want to remove calcium oxide from the blast furnace. So we are adding silicon dioxide. We are adding flux. We are adding what? Flux. So what flux we can add? Calcium oxide. For that we are adding silica. So our silica combines with calcium oxide and they produce calcium silicate, and calcium oxide is removed in the form of slag. Can you able to follow? Second step. 3 types of chemical reaction is taking place. One is the formation of carbon monoxide. The next one is removal of calcium oxide from the blast furnace in the form of calcium silicate. It is called as slag. Isn't it? Flux reacts with the gangue to produce what? Slag. The last one, the upper region, that is called as reduction zone. In this zone, the temperature prevails nearly 400 degrees Celsius, because in the middle region we studied that two reaction has been takes place, isn't it? Formation of carbon monoxide and formation of calcium oxide and carbon dioxide. These two are what reaction? We studied endothermic. In these two reaction, energy is observed. The heat energy is observed. So only the temperature from nearly 1000 degree, it really comes down. It drops to 400 degrees Celsius. And in this region, this here, the main reducing agent is carbon monoxide. Our main aim for forming coke, for using coke, is for the formation of carbon monoxide, because it only acts as a reducing agent which is going to reduce the iron oxide, that is hematite, into iron. Clear, students? So the main goal of using coke and main goal is we want to form more amount of carbon monoxide. So only the formed carbon dioxide again reacting with the carbon and they are producing more amount of carbon monoxide. Okay, in this reduction zone, the metallic oxide, that is the ferric, okay, in this region the carbon monoxide that reduce ferric oxide to form a fairly pure spongy iron, that is Fe2O3, that is ferric oxide. Fe2O3, what is that? Hematite, or you can say it as ferric oxide, undergo reaction with, now only our ore is going what? Undergoing the chemical reaction. Till that it is remain like that. Only the coke and limestone has been reacted. Now as a result of formation of more amount of carbon monoxide, there is no further coke to produce carbon dioxide, because all the cokes were burned and limestone also burned and they produced more and more carbon monoxide. Now this carbon monoxide has only one compound to react, that is called as ferric oxide, Fe2O3. So the formed carbon monoxide, they have to be converted into carbon dioxide. So they in turn combine with the oxygen that is found attached to our iron, that is found attached to ferric oxide. So our carbon monoxide undergo reaction with Fe2O3. So now what's the temperature here? Nearly 400 degrees Celsius. And all the carbon monoxide that combines with the oxygen that found attached to iron and formed as carbon dioxide, and they are liberated. Okay, the hot gases are liberated outside. Okay. Carbon dioxide gas is liberated. If any sulfur is there, sulfur dioxide gas also liberated or are oxidized, and they are removed as gas. So now see, Fe2O3 is reduced to Fe. Ferric oxide is reduced to iron. Ferric oxide is reduced to what? Iron. Okay, that is the reduction step. Now the formed iron is collected at the bottom of the furnace, and after removing the slag. What is the slag formed here? What? Calcium oxide is removed in the form of calcium silicate, where any sulfur or found attached to our that is roasted ore, means again that also will get oxidized and removed as sulfur dioxide gas. Now the iron that formed, what we get it from blast furnace, is called as cast iron. Okay, I'm sorry, it's a pig iron. Okay, that iron that's formed is pig iron. It is again remelted, again it is heated and it is melted and it is cast into different shapes. Then that iron is called as what? Cast iron. Okay, students. So from the blast furnace, what we get is called as pig iron. Okay. So this iron again it was remelted by heating. Again it was remelted and it was cast into different shapes, or it is molded into different things. And now the iron is called as cast iron. Clear? So this is a very important question. Smelting. At the book back, it is this question is given there. Okay, they explain the smelting process. Okay, so it's a very important question to learn. So I hope that you understood. That is Roman number 7. Third question, explain smelting process. So first you have to write the definitions for smelting, and this is the smelting of iron in blast furnace. You have to explain for 4 mark questions. Clear, students? It's a book back question. Smelting process. Here the major reducing agent that is used in iron is, don't forget, carbon monoxide. So for that only we are using coke and limestone. Finally formed carbon monoxide reacts with our what? Ferric oxide, and it reduced to iron. The iron that get it from the blast furnace is called pig iron. Again it is melted and made mold into different shapes, and then it is called as cast iron. Clear? And the physical properties of this iron, see, it is a grayish white in color and it's a lustrous metal it has high tensility strength, it is more strength, and it's highly malleable and ductile. And the important property of the iron, you all know that it can be magnetized. Okay, so the physical properties, it's a lustrous metal that is give shiny appearance, and the color is grayish white in color. Tensility, it has high strength, and they can be drawn into wires, that can be ductility, and they can be molded into different shapes, that is called as malleability, and it can be what? Magnetized. That is the physical properties of the iron. Okay, va? The next one, the uses of iron. Next class we will study the chemical properties. Before that, the important question, that is uses of iron. 3 types of ions are there based on the carbon content in the iron. Since we are using more coke, they may have what? Little carbon content in it. See, pig iron, steel, wrought iron. Okay, pig iron means the iron with 2 to 4.5% of carbon. Okay, that is pig iron means it contains nearly 2 to 4, it is not 100% pure iron, it may contain 2 to 4.5% of carbon in it, and it is used for making pipes, stoves, radiators, railings, manhole covers. Manhole covers means that a drainage, you can see steel cover is there, isn't it? For closing the drainage we are using, no, that one is called as manhole covers. Okay, for closing the drainages. Okay, manhole covers and drain pipes are made up of this type of iron, that is called as pig iron. Next one, steel, it has less than, that is steel means it has less than 0.2, the carbon content is very less. Okay, so the formed pig iron undergo refining process. In this refining process, the remaining impurities will be removed. So more carbon content means pig iron, less carbon content, it is steel. It is mainly used for the construction process, machinery, transmission, cable and TV towers, and also it is steel is a alloy to form. Okay, making alloys. The third one is wrought iron. It may also contain 2% of carbon in it, and it is used in making springs, anchors, and this wrought iron only can be magnetized. Okay, so these are the uses of iron. So different types of ions means you have tried 3 types of ions. What is on? Pig iron, steel iron, wrought iron. This type is based on the carbon content attached to it. More carbon content, nearly 4.5% means pig iron, less than 0.25% is steel, nearly 2% means it's a wrought iron, and it is used for different purposes. Okay, that's all about what? Iron. Next class we will discuss about the chemical properties. Students, for your test portion up to extraction of aluminium, that is page number 116. Okay, for the monthly exam you have to learn page number 106 to 116, 106 to 100 and I'm sorry, the page number, that is the first 106, periodic classification. Unit 8 is your test portion. The chapter you have to learn is 8, page number 106 to up to aluminium, that is page number 116 up to uses is added for your monthly exam. Okay, thank you students.